You know, almost everything you own, your phone, your clothes, maybe even the coffee you're drinking, it probably spent some time on a giant ship. Global shipping is this invisible engine that powers our world. But it has a bit of a dirty secret. It's under immense pressure to clean up its act. And the solution? Well, it might actually be more dangerous than the problem itself. Let's get into it.
Just try to wrap your head around that number for a second. Over 100,000 ships crisscrossing the oceans right now, carrying literally everything that makes our modern lives possible. The scale is just staggering, and all of it runs on a colossal amount of fuel.
And that's the real pickle here, isn't it? In this race to go green, the shipping industry is basically trading one kind of risk for a completely different one. So how do you solve a massive pollution problem without accidentally creating a safety disaster? The new fuels are definitely cleaner, but they come with a new and, potentially explosive catch.
So what's the leading contender to replace that old, polluting ship fuel? Well, it's liquefied natural gas, or as you'll hear everyone call it, LNG. On paper, it looks like a fantastic solution, a really critical first step towards a zero-emission future. But, as we're about to see, its benefits come with some pretty serious strings attached.
Okay, let's break this down because this is where it gets really interesting. On emissions, LNG is a huge win, no question. It slashes all the nasty stuff. But then, look at the storage temperature. It has to be kept at a cryogenic minus 162 degrees Celsius. That is unbelievably cold. And because of that, the main danger shifts from a messy but manageable oil spill to a catastrophic explosion. That's the trade-off.
And that one change, that single shift in risk from spill to explosion, it changes everything. All of a sudden, the most routine jobs, things sailors have done the same way for 100 years, become these incredibly high-stakes procedures. And there's no better example than the simple act of refueling.
In the maritime world, they've got a word for it, bunkering. You can think of it like pulling your car up to a gas pump, but just, on a completely colossal and way more dangerous scale, especially when you're dealing with LNG.
Let's just focus on this number again for a second. Minus 162 degrees Celsius. It's so cold that if even a little bit of this stuff splashed onto the normal steel of a ship's hull, that steel would become instantly brittle and could shatter like glass. Just gone. So you can see why bunkering LNG isn't just about pumping fuel. It's way more like a surgical procedure. Every single one of these steps is absolutely critical. Every connection has to be flawless. Every safety system has to be double and triple checked. The whole thing is this carefully choreographed dance between two giants.
So you might be asking yourself, how on earth did the entire world agree to take on a fuel this risky? Well, the answer is actually an amazing story of international cooperation. They created a new, globally agreed-upon safety playbook.
Now, this global rulebook didn't just appear out of nowhere. Two key organizations really led the charge. First, you have the International Maritime Organization, the IMO, which is part of the UN. And then you have these expert engineering groups called classification societies, like the American Bureau of Shipping, or ABS. Their whole mission was to figure out how to tame LNG at sea.
So the IMO created something called the IGF Code. The easiest way to think about this is that it's the international law. It sets the big, high-level goals. It's the what. It says, okay, world, this is the level of safety you must achieve to minimize risk. And then you have the guides from organizations like ABS. And if the IMO's code is the what, this is the how. This is the incredibly detailed instruction manual. It gets into the real nuts and bolts, telling engineers exactly how to design and build the systems that will meet those big safety goals. So let's see what that actually looks like.
Right, because these guides are just packed with brilliant engineering solutions, all designed to do one thing: tame this incredibly volatile and freezing cold fuel.
This is it. This is the fundamental engineering puzzle. How in the world do you build a tank that can hold something that cold right in the heart of a ship made of steel? And the solution is just brilliant. It's a defense-in-depth system. The first layer, the primary barrier, that's basically a giant thermos. But just in case that ever leaks, there's a complete second barrier right behind it ready to catch anything. And all of that is separated from the ship's actual hull by this big insulated space. It's not just a thermos. It's a thermos inside a suit of armor.
Okay, but what if something goes wrong while you're refueling? What's the failsafe? That's where the Emergency Shutdown System, or ESD, comes into play.
It's essentially a giant red stop button that the crews on both ships can hit to instantly and safely stop the fuel from flowing.
And here's the really clever part. It's not just a manual button. The whole system is connected to this network of sensors all over the ship. So if a tiny gas leak is detected, or the pressure in the tank starts to get too high, or a fire breaks out, the system doesn't wait for a human to react. It sounds an alarm and automatically triggers a shutdown, long before the situation can ever become a real disaster.
So, when you put all of this together, all this meticulous planning, all this brilliant engineering, all these fail-safes, what does it all add up to? Well, it's the invisible architecture that actually allows for progress.
And that's the real takeaway here. Without this invisible framework of rules, the switch to cleaner shipping just wouldn't be happening. The risks would be way too high for anyone to take. This detailed safety playbook is what gives the world the confidence to build and operate the ships that are going to carry our stuff more cleanly into the future.
And the best part is, this playbook isn't set in stone. It's designed to evolve. You can see it right here in the language from the IMO's code. They basically built it to be a living document. As new, even more challenging fuels are developed, new rules will be added to the book. It ensures safety always keeps pace with technology.
Which leaves us with a pretty big final thought, doesn't it? The lessons we learned from taming LNG are creating the template for the next generation of even cleaner fuels. The challenge now is to apply this same intense focus on safety to write the playbook for what's next, things like hydrogen and ammonia, to make sure that global trade can get cleaner without getting more dangerous.